Alright, hi guys. We are going to be looking today at Learning Target 5. So if you could open up your monkey packets to page 33, you should see that says Learning Target 5. And Learning Target 5 is all about learning how to graph equations and functions, basically graphing a function from a table. So what we're going to do is we're going to evaluate the following functions in order to graph them. So we got to use our function evaluation, if you remember from Learning Target 2, which just means we're going to take x and plug it into f here. We are taking whatever's on the inside, and that's going to be our input, and seeing what it gives us out, our output. Remember that f of x is the same thing as y. So we're going to pick a few numbers to choose to plug in. So what we're trying to do here is this is going to be a function, but we can't graph every single point because there's millions of points that go into one function. So what we're going to do is we're going to get a snapshot of the function by graphing some of the points. So I'm just going to pick some nice snapshot numbers that give me both positives and negatives. And those are the numbers I'm going to use for x. What I'm going to do is take those numbers and plug them in and see what I get out for y. So f of negative 2, if I plug negative 2 in for x, well then f of negative 2, f of x, y equals negative 2. F of negative 1, if I plug negative 1 in for x, then I see that f of x, my output, is just equal to negative 1. If I plug in 0, then I just see that my output is equal to 0. And the reason here you might be noticing, well, these are just the same. Well, this particular function has f of x equal to x. So because those are the same, our output and our input are the same, our output and our input over here are going to be the same. So that's why that is happening for this particular function. If I plug in 1, and then I plug in 1 for x, my output is just 1, and if I plug in 2 for x, my output is 2. Alright, so these are the points that we're going to graph, and sometimes that can be kind of hard to see when your table is so separated out like this. So sometimes I like to just take a minute, and remember that this column is our y's, it's our output, so I'm just going to write these as points so it's easier for me to graph them. Alright, so now you have your table, you have your points, and you can start to graph. So x is negative 2, y is negative 2 right here. X is negative 1, y is negative 1 right here. 0, 0 is our origin. X is 1, y is 1. X is 2, y is 2. Alright, so if I have a snapshot of this function looking like this, is this linear? Why or why not? Well, looking at this right now, you might say, yeah, it looks linear. It looks like I could put a line straight through those, but they're asking why or why not. And just because I can draw a line doesn't mean that it's necessarily linear. So if I'm looking at this graph compared to maybe if I had points that looked something like this, they're asking why is this linear and why is this not? Well, if I look at this one, it's not a line because up here, it kind of curves out, and then it goes down, and then it curves, and then it goes back up. Where here, no matter what, I'm just kind of going up, over, up, over, up, over, up, over. And that's what we talked about before. When we're just moving up and over by the same amount, that's our rate of change. That's how our line is changing between 2 points. For something to be a line, it has to have a constant rate of change. This movement, up 1, over 1, has to be consistent throughout the whole thing, and it is. Yes, the graph has a constant rate of change. Now, one thing I want to point out to you is we are graphing the whole function. Remember, I said that these are just a snapshot of our function. That's just one part. But remember, we can plug in more things. For example, I could now plug in 3, and I would get this point. I could plug in 4, and I could get this point. I could plug in numbers up to 100, a million, hundreds of millions, billions.